This is a video from section 3.9. We're going to look at problem 21. The altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 square centimeters per minute. At what rate is the base of the triangle changing when the altitude is 10 centimeters and the area is 100 square centimeters? Let h equal the altitude of the triangle in centimeters. Let b equal the base of the triangle in centimeters, and let a equal the area of the triangle. Now we know dh dt is 1 centimeter per minute, because if we go back, the altitude of a triangle is increasing at a rate of 1 centimeter per minute. So that tells me dh dt is 1 centimeter per minute. And dA dt is 2 square centimeters per minute. So the area is increasing at a rate of 2 square centimeters per minute. So that's dA dt. That signals what dA dt happens to be. So we want to find dB dt when h is 10 centimeters and a is 100 square centimeters. And you can see I drew a picture of a triangle, labeled the altitude, labeled the base. The area of a triangle is 1/2 the base times the height. And I'm going to differentiate both sides with respect to t. So dA dt is 1/2 the quantity. And applying the product rule, we get b dh dt plus h dB dt. So that's just product rule. Now, we know that dH dt is 1 centimeter per minute. So I'm going to replace dH dt with 1. We know that h, the altitude, is 10 centimeters. So I'm going to replace h with 10. And we know dA dt is 2 square centimeters per minute. So I'm going to replace dA dt with 2. So 2 is 1/2 the quantity, b times 1, plus 10 dB dt. I need to know the value of b to find dB dt. So I need to circle back to the area formula. So a equals 1/2 b times h, 1/2 the base times the height, or the altitude in other words. Now the area is 100 square centimeters, and h is 10 centimeters. So 100 is 1/2 b times 10, but half of 10 is 5, so 100 equals 5b. Divide both sides by 5, and we get b equals 20. So I'm going to plug the 20 in. So 2 equals 1/2 the quantity, 20 plus 10 dB dt. Distribute the 1/2 inside. Half of 20 is 10. Half of 10 is 5. So 10 plus 5 dB dt is equal to 2. So we're down here. Subtract 10 on both sides. And we get 5 dB dt equals -8. Divide both sides by 5. dB dt is -8/5. And if we convert that to a decimal, we get dB dt is -1.6. And so what that tells me is that the base of the triangle is decreasing at a rate of 1.6 centimeters per minute. So the base is getting smaller. That's 21. Let's take a look at 31, sticking to the themes of triangles. On 31, the sides of an equilateral triangle are increasing at a rate of 10 centimeters per minute. At what rate is the area of the triangle increasing? When the sides are 30 centimeters long. So we're going to let S equal the side of an equilateral triangle, and let A equal the area of an equilateral triangle. And so I drew a triangle, and if you notice, I started at the top and dropped a perpendicular down, and we're going to let H represent the altitude of the triangle. Okay? And when you drop the altitude down to the opposite side, the length from here, what I'm highlighting in red to here will be half the total length of the side. So in other words, that length here will be 1/2 s. By the Pythagorean theorem, I know that 1/2 s quantity squared plus h squared is equal to s squared, right? And so what I'm, again, wanting to do is I want to solve for h in terms of s. And so h squared is 3/4 s squared, and h is equal to square root of 3 over 2 times s. So what I'm doing here is I'm deriving the formula, the area formula for an equilateral triangle. So an equilateral triangle has its own specific area formula. Now, the area is 1/2 times s times h, so we get 1/2 the base times the height. But h equals square root of 3 over 2s, so I'm going to plug that in. And you can see down below, we have the following. We have a equals square root of 3 over 4 times s squared, right here. Now, we know ds dt is 10 centimeters per minute. And we want dA dt when s is equal to 30 centimeters. Okay? So I'm going to differentiate this area formula with respect to t. So dA dt is square root of 3 over 4 times 2s ds dt. But we know that s is 30 centimeters and ds dt is 10 centimeters per minute. So I'm going to replace s with 30 and ds dt with 10. And so that says dA dt is square root of 3 over 4 times 2 times 30 times 10, which is 150 square root of 3. And that tells me that the area is increasing at a rate of 150 square root of 3 square centimeters per minute. And again, you always want to double check with your instructor. Your instructor might want a decimal approximation to 150 square root of 3, but I'm going to leave it as 150 square root of 3. And that'll conclude this video for section 3.9. We worked on problems 21 and 31. Thank you.